This video is going to show you how to do translations and reflections on shapes in a coordinate graph. So the things that you're going to be asking yourself when you're looking at shapes in all four of these types of transformations is, does the shape keep its congruency? Does the image keep its orientation? So we're going to use this table right here, and we're either going to write yes or no, or you guys can put checks and X's, whichever way works better for you. So translation. If you look at this diagram, this is an example of a translation. Translation means that the shape just slides from one position to another. So you can tell A is still at the top when it moves to the new shape. C is still at the bottom when it moves to the new shape. And B is still towards the right when it moves to the new shape. So that means that yes, it keeps its congruency. And yes, it's still in the same orientation or facing the same direction. Now, when we look at the next one, a reflection, here is an example of that. A reflection is just like you're looking at yourself in the mirror. A was in the top left, but now when you look over here, A is in the top right. So it flips over. The two shapes are the exact same size, so they are congruent. I would say yes, but they're not going in the same direction. Things are opposite now, so that would be no. The next one on the list says a dilation. Sometimes you might go to the eye doctor and they're checking your eyes and they dilate your pupils so they can see inside your eyes, which means they make your pupils larger. And that's what happens with dilation. You could start with one shape and it's going to basically just change size. This might be the first shape, this little blue one, and it turned into the red one, so it enlarged. Or you could even go backwards. I could have started with the red shape and my it could shrink and turn back into the blue one. It doesn't matter which way it goes, but you can tell these two shapes are not the same size. They are not congruent. So I would say no on congruency, but they are still facing the same direction. The top point and the top point, when you look at how they're connected, they're going in the same pattern. So this would be yes for orientation. Then the last one is rotation. On this particular example, they're saying this was the first shape and then it rotated or it turned around and now it's facing a new position. You can tell that the shape is the same size triangle when you look at it. However, it's not still facing in the same direction. So I would say yes to congruent, but I would have to say no to orientation because it's not still pointing in the same way. So on this page, what we have is the coordinate graph, and the quadrants are labeled. It starts in the upper right-hand corner, and it goes counterclockwise to quadrant 2, quadrant 3, quadrant 4. Now what I'm going to put on the side is the way the ordered pairs would be labeled as in positive or negative. The quadrant 1, the numbers are positive, positive. Quadrant 2, the numbers are negative, positive. Quadrant 3, both numbers are negative. And then quadrant 4 is positive, negative. So we're going to use this as a reference point. If a shape was in quadrant 1, we would know that both numbers would be positive. And if the shape moved from quadrant 1 to quadrant 2, depending on the rule, I would know that the first number might turn negative and then the second number stay positive. That's an example of one type of rule that could happen. So we're going to use these to help us with some of our rules. The first one we're going to look at is translation, and so this kind of gives you a definition. It says that the slang term is going to be slide. The shape is just going to slide somewhere, and it's going to be measured in distance, either left or right. So that's kind of small. It might move just left or right, or it could move both positions, left, right, and then up, down. So you just have to look and see what's happening. The definitions just mean that all the points of the figure are going to move in a specific distance, either horizontally or vertically. So this particular rule says it's going to go left 4 and then down 2. So for me to go left 4, anytime on a number line I'm going left, that means I'm going to take away. So if I were to write this rule underneath here where it says left 4, that's going to translate the x value, if I go left 4, would be subtracting 4. And then it says go down 2. Instead of me putting that other parentheses there, I need to just put a comma. The y value, if I'm going down, let's say if this was a thermometer and I was doing temperature, when I go down, it's also subtracting. So the rule would be y value also take away 2 for this particular rule. Now, I'm going to actually draw this on the graph. Every point is going to go left 4 and then down 2. So if I just have to draw it, this is going to be really easy. I'm going to put, this is my original shape. It's going to go left 4 and down 2. So 1, 2, 3, 4, down 2. So this is where my new image, my top dot, is going to be right there. And then I'm going to do the same thing with all the other ones. And then I could just connect the lines. To get my new image. So again, just review, the orientation when you're doing a translation is going to stay the same. And the congruency, the shape is also going to stay the same size. Okay, then at the bottom it says that in a translation, you're going to move the points on the coordinate plane in the same direction and in the same distance. And it doesn't really matter which order we put them in. In the same direction and the same distance. So all the points, if I say go to the left 4, they're all going to move the same direction and the same distance. Okay, this example has no picture. It says just using the coordinates, follow this rule. Okay, so I have a table. This is going to help us organize and be a little bit easier to follow through since we don't have a picture to look at. The original image, the coordinates are -1, 4 for A, -5, 3 for B, and -5, -3 for C. Now, the rule says X needs to -4 and Y needs to +2. So, in this middle row right here, that says rule, I'm going to write what I'm going to do to each one of these values, and then I'll put the new quantity underneath where it says new image. Notice where you put the letters, they have apostrophes right after them so that you could tell the difference between the original image and the new image. This is also called prime. Okay, so the rule says the x value is -4 and then +2. So I'm just going to copy that all the way across. The rule, I'm doing the same distance and the same direction on all the pairs. So as I go through now, -1, go to the left 4, or I could just numerically do this. -1 and -4 makes -5. And then 4 plus 2 makes 6. Move over to coordinate B. And it says -5. I'm going to follow the same rule. Go to the left 4. -5 and -4 make -9. And then for the y value, I still need to add 2. So 3 plus 2 is 5. Now we're on the last pair, -5 and go left 4. That's the same thing. So -9 again. And then -3 plus 2 makes -1. So that's how I could do the new coordinates when I don't even have the picture. So the second type of transformation that's in this video is reflection. And a reflection basically, reflection creates a mirror image over a given line. It could go over the x-axis or it could go over the y-axis. The slang term for reflection is flip. And then we have definition. All the points are going to move in the opposite direction across the axis. And then between that line, each point is going to be the same distance away. So that'll make more sense when we actually see a picture. The orientation, it is not facing the same direction. So this is going to be not the same. But congruency, the size of the shape is going to stay the same. Okay, so on this one, at the very top, this says x-axis and this also says x-axis. We need to change one, so I'm going to change this one and make it say y-axis. So if you're in my class, please change this to also say y-axis so we can have an example of each one. Okay, the first one says flip across the x-axis. Well, this is the x-axis, so I'm going to pretend like this is the line that it has to go across. Okay, when I flip it across, see how the flat part is on the bottom? Well, now it needs to do the opposite thing. The flat part needs to go on the top of this new image. So I have flat part. And then instead of going up, it's going to go down. And then it's going to slant back. And it's kind of not the best drawing right here. But if I were to label these points like this is number 1, that's point 2, and that's point 3, 1 would now be on the bottom instead of the top. And they would look like that. Okay, same thing. When you flip across the y-axis, okay, here's your y-axis. If I pretend like this is my line I'm going across, if I number these points again, 1, 2, 3, instead of the shape pointing to the right, see how the 3 now is pointing over here to the right? It's going to be over here pointing to the left. So I'm going to draw it backwards. That might be another term we could use for a reflection is backwards. 1 would be there, 3 would be there, and 2 would be there. Okay? Now, on the bottom, it is saying what happens to the coordinates when the image is reflected or flipped across the axis. So if you noticed, if you remember this top is positive, positive. Then underneath it, this is positive, negative. Okay, when I compare these, the first number is positive and the first number is positive. That means my x value stayed the same. But my y value was positive, and now in this grouping, it's going to be negative. So when you flip across the x-axis, I'm going to write that rule now kind of in an algebra way. Let's say the original image is just always going to be xy. If they were both positive. Then if it's flipped across the x-axis, we can look right here and see what happened. It used to be positive, positive. It used to be positive, positive. Now it's going to be positive, negative. Okay? So I'm just going to write this for a general rule. And then underneath in the red font, you can take a look and see it says this negative sign doesn't always mean it's going to be negative. It means you need to change the number to have the opposite sign than what it currently did. So up here it was positive. It changed to be the opposite. It was negative. And again, when we have a real example, it's going to make a little bit more sense, I think, to you. When you go across the y-axis, over here on this example, again, quadrant 1 is positive, positive. When I flip and I go to quadrant 2, now it's negative, positive. So if I try to look and compare these, positive switched, and now it's the opposite sign. So my x values this time are now flipping, but the y value was positive and it stayed positive. So I'm going to write that. If originally it was x, y, both positives, then after it's reflected across the y-axis, the x is going to switch to be the opposite, and the y is going to stay the same. So let's try it with a real example. This one just says write the coordinates of the new image when it's reflected across the x-axis. So it's super important that you know which axis you're going across because you're going to change the values. If this is my x-axis and my shape originally is in quadrant 4, that means my values are positive, negative. If I'm going across the x-axis, it's going to move up here. And this quadrant is positive, positive. So what happens is my x value was positive. It's going to stay the same. My y value was negative. Now it's going to switch and be the opposite because instead of it being at the bottom, it's going to be at the top. So my new coordinates... I don't like that color. My new image. And remember, these are going to have apostrophes. So R apostrophe, S apostrophe, T apostrophe. When it flips across the x-axis, the x stays the same. So R would be still 3. But now instead of negative 4, it's going to switch up to here, so it's going to be positive. Same rule applies when I move to S and T. The x value stays the same. It was positive, it's going to stay positive. So 3 is going to remain positive 3. And then negative 7 is going to switch to go to the top, so it'd be positive 7. Then letter T, 8 stays the same, the x value and the y value switches, so now it would be positive 7. Okay? All right, last one has an example of going across the y-axis. Now, this one is a little bit tricky. Maybe, I don't know, because it's hovering over the x-axis itself, but remember this one says it's flipping over the y. So here's my y-axis. This one's kind of a little bit tricky, but not too bad. So this box is negative, positive. This box is negative, negative. So when I move across to the other side, and I move across to the other side, quadrant 1, remember, was positive, positive. And then quadrant 4 is positive, negative. Okay, this one does not have the coordinates written for us, so it's not quite as fast, but we'll get it. All right, the new image. These letters are E, F, G, and H. And the new image is going to have little apostrophes. That's called prime. So I'll just put mine, get mine set up. Okay, so for letter E, which is right here, start from your origin. 1, 2, 3, 4, 5. Negative 5, positive 2 was the original image. Negative 5, positive 2. This one would be negative 5, negative 2. Now when I switch them, let's look and see what happens. Okay, the negative x value, now it's going to switch and be positive. The positive y value is going to switch, and stay the same and be positive. So I'm going to write those. The new E is now positive 5, and then stay the same, positive 2. All right, moving down to letter F. Letter F was negative 5, negative 2. It's going to move over to quadrant 4, which means now your x value needs to turn positive, but your y value stays negative. So now this one would be positive 5, negative 2. Now if I repeat that same process for the H and G, G value was negative 1, negative 2. Originally, it was negative 1, negative 2. But now when it moves over here, it's going to be positive 1, negative 2. On letter H, it was negative 1, positive 2, negative 1, positive 2. But now this tells me my first number needs to be the opposite. It's going to be positive 1, and then your y value stays the same. So positive 1, positive 2. And those would be the new values. Okay, so I tried something new on this video. I used this yellow notebook paper as my background. I just wanted to get your opinion. Do you like the video using this yellow lined background, or do you prefer that solid black background that I've used in many videos before? So comment on this video and tell me which one you like better. And if you really don't care, then just say both backgrounds are fine. It doesn't matter to me. Thanks, guys.